Hey guys, so welcome to our video on movement. So we've got ourselves a bit of a scene here, with a bit of a town scene with a backdrop, some mountains and the sky, and a church with like a church graveyard and some props and stuff like that going on. We've got our main character here with his two box colliders on him, his ground check and his ceiling check on him. He's got our character himself has a box collider, rigid body, which has a freeze in the Z rotation, which we all went through in the last video. We also do have these two little things in it, which are stops. So if I double click on that, a bit too fast, they're just like box colliders, if you will. I'm going to show you two things today really quickly. I'm going to start with a really quick one, which is this cinema machine. If you go add this create 2D camera, it'll create the second camera. And just here, I've dragged in follow and look at into our main character. You have a bunch of settings that you can play with around here as well, which you can kind of play around with your own time. I might give you a video on cinema machines that kind of goes through some of the intricate details of it. But the main good thing about it is we've got these really easy follow and look at, so you don't have to code it or anything like that. It'll automatically follow your and look at your main character. If you want to like if you're doing a shooter or something like that, you can have it follow your camera and maybe look at your mouse or something like that. But that's if you wanted to. Yeah, but for now we got to, if you get like a shooting cursor or something like that. Okay, so we're going to start with some motion. So obviously our first step is we're going to create a folder and we're going to call it scripts. And then we're going to click on our main character. We're going to just minimize all these, and we're going to add a player movement new script and go create an ad. That'll add it to the player and put it down here. We're going to drag it into our scripts folder. And then we're going to double click on it and it'll open up our Unity script. Well, that's the hope. Here we go. And just a reminder for everyone, I like doing this. We're getting, and then we're saving it and closing it again, and that will change the script. And then I'm reopening it. Went through that in class. I don't know. I think it makes the suggestions work a little bit better, personally. Cool. So now we have our script. Now the first step for movement is you need to create a couple of variables. And so the first variable you want to create is a public rigid body. And we're doing a 2D, so it's a rigid body 2D. And we're going to call that RB player. So this is just a variable or that we're going to store the rigid body of the player in. You want to make a public float, and we want to call that not equals yet, and we're going to call that let's call it movement speed, and then we're going to create just a straight up float, and we're going to call that horizontal move, and that one can be empty. We might actually set this one to 10F just as default. And then we're going to press save. So those are our first three basic, our basic variables. And if we press save and we come back into our Unity, it's going to load up. And if we click on our main character here, on the script, you'll see those two variables that were public appear. And our first step, obviously, is just to drag our rigid body in to this RB player spot. So now that the script, whenever we reference this RB player, we'll know that the rigid body we're talking about is the one that's attached to our main character. Now coming back into our script, we're just going to press save here just to be safe. We can obviously just straight up get rid of this void start. In this particular case, we don't need it. And then we're going to add ourselves a void fixed update. And, you know, update called fixed number of times per frame used for physics. I can't spell. Okay, so we got 2. So remember, our first step with our movement is obviously to get that value from the player on what they've pressed, A or D. So remember, the way we do that is we get this horizontal move, and we make it equal to, and then we use this input dot get axis raw, and then we say the axis that we want to get is the horizontal axis, and we want to times that by what do we call it? Movement speed, and then end that. So what we've done here is this is the input, which references, it even tells here, the interface into the input system. Returns a value, the virtual axis identified by the axis with no smoothing filter applied, and the axis we're looking at is a horizontal, and then we're multiplying it by our movement speed. So just a quick reminder that if I add a little line down here, which is debug.log, and I write the variable horizontal move here, and then end it, and press save. Now, if I come over here into our script, into our game, and I click on the console just here, and I don't want to maximize it because we want to be able to read our console. You can see that it's returning zeros right now, and if I hold down A, it'll start returning this -10. If I hold down D, it'll start returning 10. So basically, now I can unpress play, clear our console. If we just remember, I feel like it's in project settings, input manager here, we've got all these axes here, and the horizontal axis is the negative, which is left and right, and alternative is A and D. So it's this input manager part of Unity itself, where it says, okay, if I'm holding down the left, I'm going on a negative direction along this horizontal axis called named horizontal, and I hold down D, I'm going on the positive numbers, and it's just this inbuilt Unity mechanism, which is what we're using basically, right? So just a reminder again, all it's doing at the moment is returning. We're saving a variable, and its value is being saved based on what I'm holding down on our ALD button. So come back into our code here. We don't obviously want to write that in the log. What we want to do is we actually want to move the character. So we're going to move the character based on that. And we talked a little bit about this, but there are 3 major ways of moving a character. But all physics should occur within our fixed update. So the way that I say is probably the easiest way to move a character is this. So if we called it RB player, we reference their thing, and we're adding a force to that. So we're adding a force to the rigid body that we've attached to the player, and then we're going. So we're adding this force to the player, and remember the way we add that force is by going new, and we want to add a vector, and in this case it's 2 dimensions, and then we open and close those brackets, and then we just close it off over here. But obviously we need 2 values within this new vector. So the first value will be the x-axis, and the second value will be the y-axis. So in this case, we want to put in this horizontal move in here. So if we just go horizontal move, and then we want to go 0. Yeah, because obviously we don't want to go anywhere up in the y. So remembering that this horizontal move is going to be negative 10 as we hold down A and positive 10. So basically we're adding a vector, which is a force being applied to the object in this, and this value here is its x value, and this value here is its y value. Okay. Yeah. And so if we press save here, and we come into our game, now if we hold down play, we hold A, he's being moved this way, hold D, he's being moved this way. So we're applying a force to our player. You can see he's shaking a little bit. What we might quickly do to kind of smooth this out a little bit is come in, create a new folder called materials, and in here we're going to create a 2D physics material. I'm going to call it smooth. I don't know. We're just going to call it zero friction, and we're just going to change this friction to 0. I'm going to come over into here, into our tile maps. Our ground tile map. And on this composite collider, we're just going to drag this. And then I'm going to go to our player and into his circle collider. We're going to also drag this physics material. And that should help smooth his movement a little bit. A little bit less bumpy. See, he's also a little bit faster, but he slides a little bit, probably a little bit too much. And so that's that. Maybe we don't want 0 friction. I don't know. Let's put it back up to 0.2, make it a little bit smoother, but not quite as bad. There we go. That's a bit better. Okay. Obviously, you know, you can see that I kind of get stopped by this. If I come up here, get stopped by this statue. No! So that's one way to move. You can move up the hill, it's all fine. It's one way to move. Okay, so the other way to move is obviously via velocity instead of force. So if we, instead of adding a force, we're going to add a velocity to our player. The other thing you can do is you can also times this by time. I think it's a capital T. Time. Yeah. Dot delta time. And press save. And that'll also smooth it out a little bit. It'll make it a little bit smaller as well. So if you press play now, maybe even too small. So let's turn this up to 100. Oh, yeah, let's turn it up to 200. It'll be a little bit more slower, and it'll also be a little bit more consistent. Like you won't have to worry about your computer. Anyway, that's just one other little thing you can do. Time of hill time basically takes into account how often the frame's being called. So it means that, like, you know, if your computer's running at really high speeds, it won't jut around or something like that. But let's go to the other method. So remember, this is the applying force. You get that glide effect. Now, which is, you know, you're kind of sliding a little bit. Now, the next method, you do slide a little bit, but that's mainly because of input lag, not because of the glide effect. So we're going to show you the next method. So this next method is, we're not, instead of doing add force, we're obviously going to add a velocity, give the rigid body a velocity. And instead of using that way, you do it this way with an equals sign. So we're saying the player's velocity equals new vector 2, opening the brackets, and still this horizontal move, but instead this time in here, you're going to times it by time, capital T, time dot delta time, and then press a comma and go 0, and then we end it off. Okay, so pressing save, coming across to here. Now, this way it's a little bit less slidey. But we're going to add the movement speed up a little bit. Less slidey, as you can see. No, not as much slide. More of a realistic movement. You can, you're walking up the hill. Not that slide. You can see I can walk up the hill. Personally, I think for most games, especially games like this is the preferred walking method. The other thing you'll notice is with the add velocity, you don't get as much bounce when you hit something as though. Like I'm not bouncing off it, and the force on impacts is somewhat not as good. But yeah, so that's one way. So we're going to save that. And I'm actually just going to comment this out right now. Commenting it out, so this line is no longer a thing. And if you notice, if I press save, I come to my game, I've commented it out. I'm actually just going to leave this as 100 because that's what we were using. And I come here and press play. I can't move. I've commented it out. Okay. So now we're going to look at the third method of movement. Okay. So this third method of movement is probably a little bit different from the other ones. We're also going to comment out this line for it as well. So the way that this one works is if. So you want to using some if statements and some if else statements. So start by creating your two if statements. Else if, and then curly brackets. We're going to have two if statements, else if, okay? So we're going to say if input dot get axis raw, and we're going to say, obviously we want this horizontal axis, again, horizontal. So we're going to say if this horizontal axis, I'm just going to add this second bracket on. If this is 0, so if this is less than 0, you want to come down here, and we want to do this transform. The thing is, in order to do this, I do recommend you do want to create a public transformer. So if I come up here and I go public transform, and we're just going to call it, I think we're going to call it player transformer, and just do it like that probably, and then come into our player. Then come into your player. Did I press save there? I don't think it'll let me save it until I've got rid of the errors. Let's just so this here is for this one here, and then obviously for the you shouldn't have a copy and paste code. For the other one, you obviously want to go the opposite direction, just like that. That'll get rid of the error, and you might want to comment this. So this is player. We should have been doing it before. Player movement using transform method, like that, something like that, you know. Pressing save. Now, so you got your two here. So hopefully this time it'll, because there was a bug, there was an error in the thing. So then you got your public transformer, Now you can just drag the transformer in there. You got your transformer. Okay. Okay. Now coming back to our code. So we want to go player transformer dot position. So we're getting the player's transformer and we're taking their position, and then we're making it equal transform dot right times, and then I've got negative time dot delta time times move speed. Okay, so wrong things. So we're saying the player's position equals its previous position plus. So that's what this plus equals does. It says you're equaling your current value plus this new value. So I mean, you could have done this by equaling and then writing player transform dot plus again, but that's what this little symbol does. It means it takes its initial value and then adds this on top of it rather than setting it as a new. So it equals transform dot right times time dot delta time, and then obviously we just take this again and paste it down here, removing the negative symbol, like that, and that pressing save with hopefully I don't normally move this way, so hopefully this is all G. Press play. You can see it's a little bit stronger, so we might want to take this down to 10 than our other methods. But you can see it's very smooth, very responsive for the player, no glide. The player moves very smoothly. Very smooth player movement. No input lag as much. Just very quick. But physics doesn't work very well, okay? And you can see you got more of this like jiggity as compared to the other ones. Yeah, so that is the other type of movement. Personally, I quite like it. It's very responsive. Oh, I'm falling down the hill. No. It's very quick. Yeah. But motion and like if you want a game where you're like, where you're having to worry about like, physics, knocking objects and stuff like that, I wouldn't use this. But if you're doing like a story-based game where like this kind of stuff, movement is just like kind of an added effect to the game, it's probably not a bad way to move. Yeah. So next thing we're going to talk about obviously is jumping and flipping our player. So we just got back to our script. We're just getting rid of this whole player movement section, commenting it out again, and then giving back to ourselves our old movement style, which obviously was our velocity style. So you come back into the game and press play. Obviously, sorry, we need to take this back up to 100. You're obviously moving using the velocity method. Okay, so with this velocity method, we need to create a couple of new variables. First, obviously, we need this public one, which will be our jump. Sorry, we have to call it a float first. Which would be our jump force, and we're going to set that default to 10F. Close it off. So obviously this is our public variable where you can play inside the editor with your force of jumping. And now we need two more, and they're both going to be booleans. I'm creating a public bool called jumping, and we're default setting that as false. And then we're creating another public bool and we're calling that on ground, and we're setting that to true as default. Okay, so these two new public booleans, jumping and on ground. Just gonna save that off. Now, if you come over into your editor, booleans look a little bit weird in your editor. They're these tick boxes just here as they're public. Okay, so you can see they're tick boxes. Back into our code. Okay, so now we we moved it horizontal equals input dot get access. This is how we got our whether the player's pressed holding down an arrow key. Now it works a little bit differently if we are taking in our input. And once again, unfortunately, we're going to use some if statements. So we're going to go if and then do some curly brackets. So this if's going to be we're going to if the input dot get button down. So if the player presses the button down that Unity has said is the button for labeled as jump. Okay, so if the button that Unity's allocated to jump is pressed down, so if this is true, so we're saying the statement, this button being pressed down that's been jump is true, then we want to say that the jumping boolean equals true. Okay? Then, if input dot get button up, and the button we're looking at again is this jump button, equals true, then we're going to say jumping equals false. Okay? So basically, if you press the button down, that is jump. Jumping, the boolean jumping is true. If you let go of the button, the jumping variable becomes false. So we can do this without even using a debug, because we made it public. So if you come over here and we press play, and I press space, you can see the tick goes. I let go of space, it goes away. Space, it goes. Let go of space, it goes. Okay? So we have a Boolean check to see whether we're holding the space bar down or not. Okay? I hope everyone's okay so far with that. I think it's not too bad. Not too bad. Okay? Not too bad. Now, this is where it gets a slightly more complicated. Okay? So, if, some more if else. So, if jumping equals true and on ground equals true, we want to jump So basically, if both conditions are of me holding the spacebar are true and on ground are equaling true, which by default are true, so that's obviously going to be met, we want to take in any horizontal move velocity that we're giving to the character, as well as apply the jump force. Okay, this is why you can jump on like an angle or something like that. Okay, so you can see in basic sense, because jumping's all this on ground we haven't done anything with yet. If we come over here into our game, and we press play, if you can see jump, if I hold jumping is true, I fly up in the air. Okay, But the thing that we allowed is obviously the ability to add direction to that jump. And you can see I can jump diagonally and I can jump this way diagonally and so forth. Okay? Awesome. Currently, there are obviously 2 flaws in our system. At the moment, we're only ever able to move at all if we are jumping. So if you go back into the game, you can see that I can't move left or right. And that's because I can only give a left or right. I can only move... I was holding it down too much. When I held down an arrow, okay? So we need, obviously, a counter to this, which is an else if jumping equals false. Now I'm going to go and on ground equals true. We want to be able to do this again, but instead of adding a jump force, we just have a 0, okay? So this time, if you're not holding down a jumping button and on ground is true, which it always is, we are, at the moment it always is, we can move, okay? So now we've got rid of that problem. If I press play, I can move, I can jump. Don't worry about that just yet, okay? I can, yeah. Okay, so that's all cool. There is a reason I'm slowly falling in. We'll fix it in a second, okay? Don't worry. So that's awesome. Okay, so now we need to stop the other bug, though, which is that I can jump, okay? And the way we do that, obviously, is with using this on ground. Okay, the way that this on ground works is we need 2 new methods that we're going to call, okay? They are void on collision enter 2D and void on collision exit 2D, okay? Like so. I don't know why it likes them being private, but I'm actually just going to get rid of that private part, okay? So, these 2. You're going to use them a lot, so get used to them. On collision exit, collision 2D, text returned by 2D physics callback function. So it's using the physics engine of Unity. And the way this is going to work is very simple. Okay? So if I go if, and I come here, and I go collision dot game object dot tag, I prefer using tag, equals ground. So if I enter a collision with a game object that holds the tag ground, I want to set on ground to equal true. Okay? Take this loop again. Should never copy and paste. If I exit a collision with a game object tag ground, I want you to set on ground as false. Okay? Saving it. Now, coming into Unity, in here, the spelling is very important here. You come to your grid map over here, you add a new tag like so, and you go ground, making sure you're spelling it exactly the same as you spelt it in your script. Then you come here and you tag this object as ground. Okay? So now all of my tile map, and sometimes I like to be extra cautious and just do the grid as well, but I mean, you don't have to. You'll see Just leave it untagged. It won't matter. So now, pressing play. Now if we come in here and we collect our player, on ground is true. And if I press space, on ground becomes false. See? False, I can't hold space down. The second I hit the ground, I can press it. Like I can do the bounce. But you can see when I'm off ground, on ground, off ground, on ground. So, now our player can move, he can jump. He can't move when he's in the air though. See, I can't move when I'm in the air. Now, if you wanted to be able to move when you're in the air, all you need to do is come back into here and add another else if statement. Okay? And that is jumping equals false. Oh, wrong end. And then on ground equals false. And then go like this. And then if we hold down save and do this, we can jump and we can move. But you do have this awkwardness of not coming down straight away. Like this. Which I don't really like so much. Because obviously it's giving you this... Because, yeah, it's giving you this kind of weird... I don't know what you want to call it. This weird, like... Yeah. And the way you could try and fix that is you could go... Hold on, let's try and problem solve that. Give me 2 seconds to problem solve it. Okay, so this was my problem solve. It doesn't work super well, but I don't know how you want to do it otherwise. But see, I've got jumping equals false and on ground equals false and horizontal move doesn't equal 0. So you're not moving. So now what that allows you to do is if you come in here, I hold space, I come down normally. I move and I hold space. I can like, if I'm coming down, then I slow myself and I can move, let go, I move down quickly like that. So you have like a glide function. Yeah. I mean, you could kind of, yeah. I mean, you could try and artificially create a gravitational force and like do something like, I don't know, negative jump force times 0.25 or something like that. See what that looks like. Didn't know it was afloat. And then that. Yeah, that didn't work too badly. I don't mind that. I don't know. I'm like trying to artificially create a gravitational pull. Okay? So obviously you kind of like, you're coming down still at a reasonable rate. Yeah, I mean, you can kind of play around with it yourself. Yeah, you've kind of got air movement of some form. Maybe coming down. Yeah, I mean, that's my attempt at it anyway, okay? So that is, if you wanted to create some form of... And you could play around with the force here, like maybe changing it to be... If you made it a little bit less, so let's go, I don't know, 0.1F. You come down a little bit slower. So you get a bit more movement. Yeah. As I said, I prefer not having air movement at all and just But you can if you want, okay? I personally think that this is the better way to do it and not having the player able to, like, glide in the air. But if you want the player to be able to glide in the air, that's all sweet. So now, as you can see, we've got movement and we've got our jump, like so, and we've got movement. Now, the last thing we want to do is obviously we need to be able to, it's particularly important once you start adding animations. You want to be able to flip your player, okay? So that's the last thing we need to do, and I'm going to show you is player flipping. And I know my script is looking a bit weird with all these commented out sections, but the way that we're going to flip our character is up here in this original section here, up here. We're going to play around with this here. And I would say that it doesn't really matter when you do it. Things happen pretty quickly. So I'm just going to do it down here. And so we're starting with 2 ifs again, okay? Now, it's important that you make sure this is an if. This is an if and an if else, not an else. So else if, not else, because it'll really wreck your flipping. Because basically you don't want to flip them if you haven't done anything. And that's quite important. Okay, so basically we're going to take just a quick recap. You should remember that this horizontal move value, it becomes, it basically becomes, if I can make this 0, if I'm saying it's greater than 0, that means you're going to your right, and if I'm saying this horizontal move, should put copy and paste, I say that and then I do it all the time. If I'm saying it's less than 0, you're obviously going to the left. And so all you're doing here is we're using this, you've seen me use this player transform before. It's what we used when we were moving our player use that way. But this time you're using a new thing called Euler's angles. And this is the rotation in Euler's angles in degrees, basically. So it lets you use degrees, basically. It's just don't worry about it. It's letting you use apply a vector in the form of degrees. So we need a 3D vector, and basically this is saying you have, let's just go 0, 0, 0, because that's actually what we want to do for the first one. So basically in degrees, you're rotating this guy 0 in the x-axis, 0 in the y-axis, and 0 in the z-axis. Okay? And this is an equals, right? This is not a rotate. This is an equals. That's saying the player's new rotation equals this here, okay? So it's not applying it. Remember, like back here when we're saying equals, we're saying this player's angles are set to this. That's very important because if you want to rotate something as it's being hit or something like that, that's a very different mathematical thing, okay? To saying it equals a new thing. And then we're doing that again. I feel like, there's that conversation about, modeling good habits and I'm modeling bad habits. And this time we're saying that this is 180, okay? So basically, if I'm holding down D, I'm going to set my rotation to this. If I'm holding down A, my rotation is being set to this. And that's literally all there is to it. So, if we go into game mode, you can kind of see my hair flick is this way. As I hold down D, it stays that way. As I go the other way, it flicks the other way. My player's rotating as I move. That's pretty awesome. And the reason this is particularly important is because when I do my animations, it means I only have to do my animations in one direction because they'll work in the other direction because they'll just be flipped. And that's really it for this video on movement. We've gone through the basics. I am going to make another video on top-down mechanics. But for this video, that's hopefully goes through the movement again. Hopefully I didn't do it too quickly. And everyone can kind of pause and copy along and get their movement up and running.